With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so today's question is the Kilian-Fischer synthesis lengthens an aldose carbon chain by adding one carbon atom to the aldehyde end of the aldose. The result of this process is a chain lengthened sugar with a new carbon atom at C1 and the former aldehyde group now at C2. This synthesis is useful both for determining the structure of existing sugars and for synthesizing new sugars. The most common method used to shorten sugar chains is the Ruff degradation. The Ruff degradation is used mainly for structure determination and synthesis of new sugars. Rough degradation of D-arabinose gives D-erythrose. The Kilian-Fischer synthesis converts D-erythrose into a mixture of D-arabinose and D-ribose. Draw out these reactions and give the structure of D-ribose. So we have to do the rough degradation of D-arabinose into D-erythrose first. That's what we need to do. So let me draw the structure of D-arabinose. So D-arabinose is basically we have 5 carbons, 2, 3, and here we have CHO, here CH2OH, and for arabinose here OH is on the right, here H is on the right, and this is the structure of D-arabinose. So this is the D-arabinose molecule. This is the Fischer form. Now what do we do is, for rough degradation we react it with bromine and water. So what will happen? Bromine water oxidizes this aldehyde into carboxylic acid. So we have CH2OH, OH, 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 H, H, and here we have C double bond OH. This is oxidation. Now we use a base CaCO3 which will abstract the acidic proton. So we have the product like COO minus. This is our product. Now what do? Now we add a peroxide initiator like H2O2. So what will happen? H2O2 will break its bond to form corresponding OH dot. So OH dot will be formed and this OH dot will abstract this proton. So it will form corresponding dot here. So this will be the process that is happening. There is a slight mistake. So this what happens here is actually so the actual step is, here we have H, here we have OH, and this OH dot actually abstracts the proton from this, and this will go as O dot. So in that step the product we obtain is 1, 2, 3 CH2OH, COO minus, and here we have O dot, here we have OH. So this is obtained. Now we add iron 3 as a 1 oxide so it will abstract a proton. It is a oxidizing agent, so it will abstract 1 electron from this. So what will happen? 1 electron from this will be absorbed and we get a O dot. So we get product like 1, 2, 3 O dot H, OH, OH, H, H, CH2OH, C double bond O, and we got O dot. So now we have got this. Now what will happen? Now the degradation of the ring will take place. So this bond will break to form radical initiation, and similarly this will be formed. So we get the product, which is the rough degradation product, which is 1 2 OH OH CH2 OH CHO. This is D-erythrose. So this is the rough degradation. So this procedure is known as, so this entire procedure is known as rough degradation. So we have removed one carbon, so decreased it to D-erythrose. So D-arabinose to D-erythrose. Now second step is asking Kilian-Fischer synthesis converts D-erythrose to a mixture of D-arabinose and D-ribose. Draw out these reactions and give structure of D-ribose. So we have now the next step, the step is for increasing the carbon number. So it is Kilian-Fischer synthesis. So we have this OH, OH, H, D-erythrose, which is drawn earlier, and we have, and then what do we add? We add cyanide nucleophile we add. So it will attack the carbonyl carbon and form hydrocyanohydrin, sorry, OH, OH, H, CH2OH. Here we have C, Cn, O minus, and H. So we get this step. This is using NaCN HCl. So we had added this. Then what happens is there will be H plus source. So once we get H plus, it will form. So it can form something like 1, 2, OH, OH, and here we have Cn. Here either it can be OH here H, or it can be like the other way. The OH can be around. So we have OH here. This will be arabinose model. So we can have this, and we have Cn here. Now what happens? This will be reduced using hydrogen palladium. Cyano group will be reduced using hydrogen palladium carbon in barium sulfate hydrogen. So this reduction will take place. So what happens? We get one product like this, OH, OH, CH2OH, H, 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 and this will reduce it to C double bond NH, double bond NH, and we have, so this will be 3 C, sorry, there is only one, yeah, sorry, we will have this form also, this form, H, OH, OH, CH2, OH, and here we have H, H. So this will be the products obtained. Now we just add H plus H2O, which will break them into, convert them into aldehydes. So we have increased the carbon number. Sorry, I will just, here I am drawing it simultaneously. 1, 2, 3. Here we have CHO. 1, 2, 3. Here also CHO, CH2OH, CH2OH. Here one OH is present. H, OH, OH, H, H, OH, OH, OH. So we got now ribose plus arabinose. So this one is D-ribose, and the left one is D-arabinose. So this is what is called Kilian synthesis, Kilian-Fischer synthesis. This is done. So that was the reaction. That was it all about. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.